Finally, something interesting is happening in AI. For years, the industry has followed one simple idea. If you want a more capable model, you make it bigger. Some of the largest open models now have more than 1 trillion parameters and require enormous amounts of computing power just to run. But here's the strange part. You can give some of these massive language models an image and ask a simple question like, "What am I looking at?" And sometimes the answer is nothing. They can process text incredibly well, but they simply can't see. Now imagine a model that's dramatically smaller, can run locally on consumer hardware, and still understands images. That sounds almost impossible, but it exists. It's called Gemma 4, developed by Google DeepMind. Gemma 4 is open, lightweight enough to run on a laptop, and has already seen hundreds of millions of downloads. What makes it especially interesting isn't just its size, but the architecture behind its multimodal capabilities. DeepMind didn't simply make a smaller version of a massive AI system. They approached the problem differently and recently revealed much more about how Gemma 4 is able to see, understand, and reason across different types of information. Traditional multimodal AI systems are often built from several specialized neural networks. If you want the model to understand an image, you add a vision model. If you want it to understand audio, you add an audio encoder. Each component processes its own type of information and then passes a representation to the main language model. It works, but it also makes the entire system larger and more complicated. Gemma 4 takes a different approach. Instead of relying on a separate vision system to interpret every image first, the image can be divided into small patches and projected directly into the model's internal representation. The model can then learn to interpret the visual information itself, including where different parts of the image came from. The same idea extends to audio. Instead of relying on another large specialized network, audio can be divided into very small segments and converted into tokens that enter the same main transformer. So rather than having one system for seeing, another for listening, and another for reasoning, the model learns to handle all of these forms of information together. And that's one of the most interesting ideas behind Gemma 4. The model doesn't need hundreds of millions of additional specialist parameters just to understand different inputs. The boundary between perception and reasoning becomes much smaller, and the result is a model that performs far above what you might expect from its size. It can understand images, process audio, work with text, and reason across all of these inputs while remaining small enough to run locally. That's what makes this so interesting. You aren't looking at an enormous model that requires a data center just to function. This is something developers, researchers, and enthusiasts can actually download and use themselves. And there are two other things worth mentioning. First, the Gemma ecosystem is continuing to evolve, with ongoing improvements aimed at making these models faster and more capable. Second, DeepMind has shared important details about the architecture behind Gemma 4. That matters because these ideas aren't useful only for Gemma. Researchers can study them, improve them, and potentially apply similar techniques to other AI systems. In other words, the architecture itself could become part of the next generation of multimodal AI. And that's why I think this release is bigger than simply getting another powerful open model. We're starting to see a shift in how AI progress is measured. For a long time, bigger models dominated the conversation. More parameters, more GPUs, more data, and more infrastructure. But Gemma 4 shows another possible direction. Maybe the future isn't about making every model enormous. Maybe it's about designing smarter architectures that can do more with dramatically less. And we shouldn't take open models like this for granted. The fact that increasingly capable AI systems are being released openly gives researchers, students, developers, and millions of other people access to technology that would otherwise require enormous resources. That kind of openness can accelerate the entire ecosystem. And if these architectural ideas continue to improve, the next generation of AI might not simply be larger. It could be smaller, faster, more efficient, and far more accessible. That's what makes Gemma 4 so exciting. The real breakthrough isn't just that a small model can see, it's that we're learning how much intelligence can be achieved when the architecture is designed differently.